Unit 11 begins our study of area of shapes. So we're starting with circles since we just left those in Unit 10. So a couple things to remember about circles. Do we know what a circumference of a circle is?
The area, I think.
Say again?
The area, or like the radius.
It has to do with the radius. Say again? It's the distance around the circle. So if we're looking at the circumference of a circle, we're just trying to see how long it takes to go all the way around a circle. Not in degrees, but in like inches, feet, centimeters, meters, where we're actually measuring the distance around a circle. Again, not in degrees, not the angle around a circle, which is 360, but the actual distance around a circle. Because the distance around a circle can be represented by these two formulas, which is c equal to 2 pi r, or c equal to pi times diameter, which are formulas from middle school, we should look familiar. We know that circumference has everything to do with either the radius or diameter, which are related to each other, and pi. So in this class, we've kind of talked about pi, sort of. But for us, we're going to be able to use the pi button on our calculator. So just so you know that, we're not leaving our answers in terms of pi for this class. If you're going to an advanced class next year, you might be, because you'll probably be measuring in radians, which we'll talk about later. But for us, and it turned out really light on my copy, I'm not sure about yours, but to get a pi on the calculator for me, you're going to press the second button, which is the blue button, and then the up caret for exponent. So if you look at your calculator right now, right above the button with the up caret is a blue pi. That's the button you're going to use for pi. You're not going to type 3.14. You're going to use the pi button because we want to be super accurate with our values here. But pi is the ratio of a circle's circumference to its diameter. It has everything to do with all the way around a circle and its circumference versus its radian measure. And it has to do with a unit circle, which if you take pre-cal next year, you'll understand what I'm talking about then. So if we look, I've done all the problems for you today because honestly, you've done a lot of this in 8th grade, so it's really just a review. If we're trying to find the circumference of a circle with a radius of 9 meters, all we do is plug 9 into the formula. We press 2 times pi times 9 on our calculator, and we get the answer. Same thing if I'm trying to find the diameter of a circle with a circumference of 17 feet, I put the 17 where the circumference goes, and I solve for d by dividing by pi on both sides. So all I have to do is 17 divided by pi using the pi button on my calculator, and we would get our answer of 5.411 feet. Notice that neither of these two values are angle measurements. Again, diameter, circumference, radius are all distances, so I like to put the unit behind it, and I will ask that you do the same. Your science teachers will be very happy with me if I make you do that. For number 2, it's very interesting because it gives you a tire and it wants you to decide how far the tire travels when it makes 15 revolutions. So how far would your car go if your wheels spin 15 times? So to do this, we find the circumference. And again, my copy ended up really light. Can y'all read yours better than you can on my screen? Like, is it dark enough for you to see? Yeah, I don't know why my copy ended up really light. But what did I do right here in this first part? Obviously, it says find circumference. But what did I do here with all these numbers added together? Say again? I plugged it all in because we're looking for the entire diameter, which is all the way across that tire, which is the part of the tire at the top, the rim, and then the part of the tire at the bottom. So I added all of those together, so I had an entire diameter for this circle. So if you wanted to highlight that for yourself, we're finding the circumference, which I did in red, and we got the circumference to be 81.681 inches. Since that's the distance around one revolution, one distance around the circumference, to do 15 revolutions, all we do is multiply that number by 15. So I can do 15 revolutions. If it asked you for this answer in inches, this would be done. But notice that the question says the nearest foot. How many inches are in a foot? 12. So I took the number of inches I had and I divided it by 12 inches so I could get it in terms of feet. And so I threw that in my calculator and I got 102 feet. Again, circumference, diameter, radius is all things you covered in middle school, which I know for some of us was a significant amount of time ago. But that's okay. It's in our noggin somewhere. What's new today for you, what you did not cover in middle school, is arc length. Now I want you to highlight arc length in a color you have not used yet, and you're going to use that for arc length throughout all of your notes. For me, I'm using blue. Arc length is going to be confusing if you accidentally confuse it with arc measure. Before today, when we were studying arcs, our answers were all in degrees because that was an arc measure. When we're talking about arc length, we're actually talking about the distance around the circle, not the degrees, but the distance. The degrees is your arc measure. So if you see in this picture, I try to make it known that this degree, this angle, is your arc measure, since the central angle and the arc are the same. But the distance around here is your arc length. Now we have this formula that we're going to set up. It's a proportion, and we're really good at solving proportions. So I'm not really worried about the algebra that goes along with this, but the setup is important. Your proportion should be the arc measure in degrees divided by 360 degrees. So degree over degree. That's how you keep it organized in your head. Should be equal to the arc length. Generally, that's what we're solving for over the circumference. It says 2 pi r right there, but that's the formula for circumference. So all we have to do is set up this proportion and we can solve for arc length. Okay? If we look at this first problem, before I did anything with my proportion, what did I do right here? What is C standing for in these notes? Circumference. So you always need to make sure you know your circumference because that circumference goes in the formula itself. So we have the circumference with the arc length above it. And we're setting that equal to the arc measure over 360 degrees. So in this problem, my arc measure is 60. My arc length is AB, that's what I'm looking for. And my circumference is the 50.265. Once we have the proportion set up, we have an X with what we're looking for, which was the arc length. We cross multiply, we divide, we have our answer. Okay, number 4 is an exact example just like it. I don't even really want to spend time going over it with me. You guys have the ability to see how I'd solve that one. But number 5 we're going to focus on. For the circumference of circle Z, how come I didn't have a little part right here where I said C equal to something? We don't have, okay, you're on the right track. If you notice, this formula is 2 pi r. Do I have a radius? No, so we can't use the regular circumference formula to find circumference if we don't have a radius or a diameter. So instead, I'm going to fill in what I know. I know from this picture that the measure of the arc is 40. I also know that the length of the arc is 4.19. See how it says inches? Inches means it's a length instead of a measure. I leave the X right where circumference should go, since that's what I'm missing. But the moment you fill all of this out and you have one variable, you can cross multiply and divide. So we multiply like the butterfly method, divide by the number in front of X, and we get our circumference. So this proportion can be used to solve for any part of those three things: the arc measure, degrees, the arc length, inches, or the circumference, inches. In fact, number 6 asks you for the arc measure. Do you see how there's this little bitty M in front of arc? That's asking you for the degree measure or the arc measure of that arc. So if I see what I have, I know that I need to find the circumference because we use that in the formula. So I have C equal to something, and that something goes in the bottom of my proportion. I see that this degree right here, or this arc measure, nope, I said the wrong word, arc length is 44 meters. I am looking for the measure of this arc. Once you have the X in place, you can cross multiply and divide to get your answer. Again, the algebra we're pretty good at, so we're not going to spend thinking time on the notes. You have them there as a reference for when you do your problems later with your group. If you want to put a nice cloud around this, this is the formula you're using. Again, your arc measure is the degrees. Arc length is a unit of length, so like meters, centimeters. And your 2 pi r is your circumference, which we can find using our skills from middle school. So if I add a little bit of color here, this is the arc measure. Arc measure is degrees. That's going to be the one thing that gets you. Green is degrees, blue is a length of measure. So we talked about circumference, and then we talked about length of an arc. So what I want you to realize is we were basically like taking the entire circumference and only taking a small part of it. So the circumference is the length all the way around the circle. An arc length is just part. We can apply these same ideas to area. So arc length is like the length of the pizza crust. Flip your paper over. On the back, we're going to talk about area of a circle. The area of a circle, again, review from middle school. The formula is pi r squared. So we can use that formula like in question 7, parts A and B. To find the area, it says the area of a circle with radius 2.5. I plug 2.5 in for radius. I press pi on my calculator, parentheses 2.5 squared, and it gives me the area. Notice now that my units are squared, so it's square centimeters. That's how we measure area. And again, you have E right there as well. But what's important here is, like on the front, when we found that part of the circumference is called the arc length, part of the entire area of the circle is going to be called a sector. So a sector area, we're gonna apply this one in blue again. I know blue was your arc length on the front side, but whatever color you use there, I want you to use again. Because it's the same idea. A sector is just simply part of the entire area. So like the arc length was part of the circumference, the sector area is part of the area. So if we look at our formula we're going to be using, we still need that arc measure. That's in degrees. So that's this part right here, the degree measure of your central angle or arc. But my area of a circle goes on the bottom this time instead of circumference. Sorry, that should be purple. And on top is that area of the sector. So it's still just, these formulas are pretty easy to remember. As long as you get degree over degree, part over whole, that's exactly what you want. The sector is part of the area itself. So if I was coloring this in, this entire piece right here, the whole pizza pie slice, the area of that slice is the sector area, not just the outside, but the whole thing. However, remember we still need this arc measure here for that sector. So it's still part of the whole thing. This time it's just part of the area instead of part of the circumference. So if we look at the problems here for this one, again, we are going to cross multiply to solve. I did before, just like I did now, before I start the proportion, I had to actually find that area. So we take a second to find area since that goes in my formula. So the area of this circle, that is off screen right now, is 50.27 centimeters squared. So that number goes in the area portion of my proportion. I can see that the shaded sector Q has an arc measure of 140 degrees. That's how long it takes to go around the arc itself in degrees. And we're looking for that sector area. We can cross multiply, we can divide. I know we have those algebra skills, so now you just have a good example to remind you what to do. For part B though, you're going to see questions like this that says, find the area of the unshaded sector for circle Q. Before I wrote it on there, Did we know the arc measure of this unshaded region? Was it listed there? I mean, I wrote it, but no, you have to figure it out. How did I know that this is 220 degrees? Yeah, all the way around a circle is how many degrees? 360. And if this much is 140, I can just take that away from 360 to get 220. So if you need to make a note for yourself, we did 360 degrees minus 140 degrees to get 220 degrees, since it's everything left. So that becomes the new arc measure in my problem. I want the unshaded region, which has an arc measure of 220 degrees over that 360. I'm still looking for the area of the sector, and the area of the entire circle is still 50.27. The setup is everything. You cross multiply, you divide, that's all in a calculator. Again, the units when you're doing area are square units, so centimeters squared. This problem number 9 says find the area of circle Y. So this time I didn't give you enough information to find the area. We don't know the radius. So instead, I have to use my proportions in a different way. I know that the arc measure is 25 degrees. That goes over the 360 degrees. It tells me that this shaded region right here, sort of shaded, is 4.1 square feet, which means I have a missing area of the entire circle that I can solve for in this proportion. We cross multiply, we divide, we find the area of that circle. Okay, again, it's just a part over the whole, either part of the circumference over the circumference or part of the area, a sector, over the area itself. The last bit of today's notes is measuring angles in radians. So we've never done this before, but angles that we are used to measuring are always measured in degrees. But that's not the best or only way to measure an angle. If you're taking pre-cal next year, you will be measuring most of your angles, or if you're taking dual credit trig, you'll be measuring most of your angles in radians, which is just another way to measure angles. The same way you can measure things in feet or in inches, still a way to measure the length of something, it's just a different unit. Radians are a different unit for angles. So to convert, what we're going to be worried about in this class, converting from radians to degrees or degrees to radians just requires these two formulas. So we're going to put a little cloud around this. To convert a degree measure to radians, you are going to multiply that degree measure by pi over 180. To convert a radian measurement to degree, you're going to do radian measure times 180 over pi. Now, in these problems, you are not pressing the pi button. When you are converting from radians to degrees or degrees to radians, you don't use the pi button because it will give you a decimal. And we want to see this in terms of pi is what this is called, in terms of pi. So you're leaving pi in your answer, which means we're not actually pressing the pi button on our calculator. To convert 60 degrees to radians, so I have degrees and I want radians. If I have degrees, I'm going to use the formula that says degree in it. So we see I took the 60 degrees and I multiplied it by this conversion factor of pi over 180. To do this really simply, you take the 60, you put it in the top of the fraction. Notice I did not press the pi button. You see this 0 and this 0 on top and bottom? They cancel out. What is 6 over 18? 3 on the bottom, so it's 1/3. So this ends up being pi over 3. You leave the pi there. If you're like, Miss Quickly, I did not follow this step right here, what you do in your calculator is you literally put 60 divided by 180 without the pi, and then you will reduce it to the number 1/3, and you can just stick the pi back on there. To convert the other way, to go from radians to degrees, oops, didn't stick. To go from radians to degrees, I'm going to take that radian measure 5 pi over 6. See, the pi is in it. We leave them there in radians. And I'm going to multiply it by this conversion factor of 180 over pi. So here we go. 5 pi over 6 times 180 over pi. If you remember your fraction rules from elementary school, it's top times top, bottom times bottom. However, if there is something on top and on bottom, they can just cancel out. So the pi cancels out, and all I have is 5 times 180, which is 900, divided by 6, which is 150 degrees. Okay? I know that these notes were basically just pieces of information for you. There was not much that we worked out because I want you to have the most thinking time on your activity for today. But you have nice, neat examples to look at and to work with as you work through your levels for today.